So then the second one is cluster, and the third one is stratified. And the two we talked about yesterday were simple, random sampling, and then census. Census is we just sample everyone. Systematic random sampling is when we sample members from a larger population are selected according to a
Sorry. Random number. Random.
random is right starting point.
Yes.
This interval, called the sampling interval, is calculated by dividing
What is a
fixed periodic interval. This interval, called the sampling interval, is calculated by dividing the population size by the desired sample size. See how it says desired? You get to pick the sample size. I like to call this systematic because there's an M and a K. I know that's not a K, but it sounds like a K. There's an M and a K variables involved in this one. There's the M, which is your periodic interval. Notice there's 4 dudes. I call them dudes because they all look bald. So, sorry. Dudettes and dudes. So in this case, M would be 4. And then you can tell they've circled the third dude in each interval. So K would be our starting point. K equals 3 is our starting point.
It was a good.
So then, to generate a systematic random sample, you divide the population size by your sample size, and you round down to the nearest whole number, M. Then you use a random number generator to obtain that K value that's between 1 and M. And then you select for the sample all of those members of the population that are K, K plus M, K plus 2M. So you're adding on, in this case, 4 each time, right? So plus 4 would be 7, plus 2 times 4, so plus 8 would be 11, plus 3 times 4,
Plus 3.
right? Because we would do 3 times the M value, which is that interval value, the 4. So you're basically just adding on 4 each time to get into that next interval. So let's say Monroe High School has 1,207 students. 1,027 students. Grades 7 through 12. They desire classes of size 15. Identify the population and sample. That's the population. That's the sample. I just labeled them P and S. And then to follow steps A to C above, so step A, divide the population, 1,027, by our sample size, 15, and that is 68.47, so we just rounded to 68. And then we would use a random number generator, which I actually did earlier, and I got 49. And then to find out C, I would do 49, and then 49 plus 2 times 68, no, plus 68. And then 49 plus 2 times 68. And then 49
So
plus,
you have to solve all of them?
yeah, you would just, and then we would do that 15 times.
15.
since the class size is 15.
Oh, mercy. Okay, like September.
So we're going, hey, you could probably do some of this in your head, but you're going 49, nope, 49 plus 68, it's 117, so we have 49, 117, and you could do 49 plus 2 times 68, that's 185. Yes, but I'm showing you this. 49 plus 3 times 68 is 253. Now, as Justin was about to mention, you could just go plus 68. 321 plus 68. If you're using a graphing calculator, I would even recommend using a table, and it would just all populate for you. But you get the idea. These would be the students in this 1,027 student body that would wind up in this class. If you think about the alphabetical list and everyone's assigned a number, and I've got student 49 and 117, and so kind of have this random group in my class until I got to 15. We're going to do,
The 49, was that, what two numbers did you have to, like 1 to what?
To get-
That was-
okay, 1 to 68.
To 68, so it's to the sample size?
Yep.
Okay.
So I go, not the sample size, but my M value. It's
And
1 to M. M is calculated by dividing the population by the sample size.
And sample size you choose.
You choose,
Okay.
yes. So I'm not gonna do it again, but if I have 1 to 68 and whatever, so then it would be every 16th.
Okay.
16 would be my K value.